Welcome, everyone. My name is Benjamin King, and in this video, I will give an overview of training materials we have developed as part of the Maine INBRE program on how to use cloud-based bioinformatics tools. Maine INBRE has several bioinformatics courses where we teach students and scientists on how to apply computational tools in their research. In our introductory courses, we begin by showing web-based tools such as Galaxy, where we can focus on teaching the basics of different analysis workflows. An advantage of using these resources like Galaxy is ease of use, as they can be run just using a web browser. There's also no cost or IT infrastructure needed. The limitations are that not all tools are available at the public instance of Galaxy, and there are also storage limitations. In advanced courses, we show students how to use Linux servers in clusters in order to overcome these limitations. The strengths in learning how to use the Linux environment is that any tool can be used after it is installed on the system. And then, of course, new tools can be developed. Data and computational capacity can also be vast. The limitations, however, are that users need to be able to access that server. And they also need to have the software installed by someone, and for that person to also maintain the server and back up the data. A key limitation is that many of the students and scientists that participate in our trainings often don't have access to a similar system or computational environment. Their institutions may just be too small to have on-site high-performance computing resources. To help students and researchers overcome these limitations, cloud computing technologies can be used. There are several commercial cloud-based service providers, such as Google with their Google Cloud Platform, or Amazon Web Services, and also Microsoft Azure. These cloud service providers make it possible to essentially design your own computing environment, and with a particular hardware architecture and storage capacity. We have used these cloud service providers in some of our courses, and an advantage, of course, is that it's possible to scale up the number of servers that you have to match the number of participants in your course. Therefore, it's possible, instead of using a centralized server, every student has their own. Furthermore, it's possible that students can access that same computing environment after the course is over. To effectively use cloud computing technologies, there is some work that needs to be done up front. As shown in the green cloud, the first step is to set up user accounts and billing. Often this requires having institutions sign agreements with a particular cloud provider and then working with the IT department at your institution to have those accounts created. Using training materials provided by the NIH STRIDES program, users can then learn how to navigate through the web portal that is used by a particular cloud computing provider. The STRIDES program facilitates the application of cloud computing using all three major commercial providers. Here at Maine INBRE, we've developed several training modules, and these are all focused on a RNA sequencing analysis workflow, featuring a data set that was generated here at the University of Maine by Sally Malloy's laboratory. In tutorial 1, we go through a workflow where the data that is analyzed is a subset of the complete data set. In that tutorial, only 2 samples and only 50,000 reads per sample are analyzed. We did this so that the tutorial would run very, very quickly. An expanded tutorial shows you how to analyze the complete data set for all the samples and, of course, all of the reads for those samples. The second tutorial uses SnakeMake as a way to automate the analysis workflow. These workflows generate read counts, and the third tutorial features generating a list of differentially expressed genes from the read counts generated in the earlier tutorials. All of our training materials have been posted on a public GitHub repository. And at GitHub, one can access written training materials as well as the IPython notebooks that step you through each part of the analysis workflow. The IPython notebooks that we developed are usable on any of the major cloud computing providers. In these training modules, we feature using Google Cloud Platform, or GCP. In these tutorials, we show you how to import the IPython notebook in what's called an AI Vertex workbench. Once the IPython notebook is imported, all the steps in the workflow can be executed. I would like to close by acknowledging the great team that we've worked with to develop these training materials. This project has involved several people at the NIH, including the NIH STRIDES program, as well as Google, Deloitte, and other members of the Maine INBRE. Thank you, and I look forward to showing you the other tutorials.